Artificial intelligence. It is the type of intelligence displayed by machines as opposed to natural intelligence displayed by animals, including humans. The distinction between the first and second categories is usually revealed by the chosen abbreviation. Strong AI is often labeled as artificial general intelligence, while attempts to mimic natural intelligence are referred to as artificial biological intelligence. Leading AI textbooks define the field as the study of intelligent agents. Colloquially, the term artificial intelligence is often used to describe machines that mimic cognitive functions such as learning and problem-solving that humans associate with the human mind. As machines become more and more capable, tasks deemed to require intelligence are often removed from the definition of AI, a phenomenon known as the AI effect. Artificial intelligence studies are often aimed at developing artificial methods that mimic human thinking. But not limited to this. New directions are emerging towards an artificial intelligence concept that can learn and develop independently of human intelligence in the future. This orientation is a product of her dream of creating superhuman beings, perhaps more intelligent than herself, who can assist her in her effort to understand the universe and nature. It was expressed in the works of Karel Čapek, one of the leading writers of modern science fiction, written in the 1920s and later influenced by Isaac Asimov. Karel Čapek, in the theater play R.U.R., by addressing the common social problems of humanity with artificial intelligence robots, predicted that artificial intelligence could develop independently of the human mind in 1920. Artificial intelligence, according to an idealized approach, it is an artificial operating system unique to human intelligence that is expected to exhibit higher cognitive functions or autonomous behaviors such as perception, learning, connecting plural concepts, thinking, reasoning, problem-solving, communication, inference, and decision-making. This system should also be able to generate reactions from its thoughts and physically express these reactions. Development process. Early research in neural networks. One of the first studies on artificial intelligence with its idealized definition was made by McCulloch and Pitts. The computational model these researchers proposed using artificial neurons was based on propositional logic, physiology, and Turing's theory of computation. They showed that any computable function can be computed with networks of neurons, and that logical and/or operations can be performed. They also suggested that if these network structures are properly defined, they can gain learning ability. Realizing learning artificial neural networks became possible when Hebb proposed a simple rule to change the strength of connections between nerve cells. Later, Newell and Simon developed the General Problem Solver, the first program produced according to the approach of thinking like a human. Later, Simon put forward the physical symbol hypothesis, and this theory formed the starting point of those who work on making intelligent systems independent of human beings. This definition of Simon is important in terms of clarifying the intelligence-emergence of two different trends in the approach of scientists to artificial intelligence: symbolic artificial intelligence and cybernetic artificial new approaches. Symbolic artificial intelligence. In the years after Simon's symbolic approach, logic-based studies dominated, and some artificial problems and worlds were used to show the performances of the programs. Later, these problems were accused of being toy worlds that did not represent real life in any way, and it was argued that artificial intelligence could only be successful in these areas and could not scale to solving real-life problems. The main reason behind the poor performance of the developed programs when faced with real problems was that these programs failed in processes such as making sense, making connections, and reasoning by simply simulating syntactic processes. Developed by Weizenbaum, one of the most famous programs of this period, Eliza seemed to be able to chat with the person in front of her, but was only doing some operations on the sentences of the person in front of her. During the first machine translation studies, support for these studies was stopped when similar approaches were used and very ridiculous translations were encountered. These inadequacies were actually due to insufficient study of the semantic processes in the human brain. Cybernetic artificial intelligence. It was the same on the cybernetic front, where neural network studies were involved. Many researchers halted their work when some important deficiencies in the basic structures used in these studies to simulate intelligent behavior were revealed. The most basic example of this is that the studies on artificial neural networks seem to have been cut with a knife when Marvin Minsky and Seymour Papert stated in their book Perceptrons, published in 1969, that single-layered sensors cannot solve some simple problems, and that the same sterility should be expected in multi-layered algae. The main reason for the failure of the cybernetic current is similarly the fact that the artificial neural network succeeds in a single-layer task, but the conclusions or results about this task turn into a judgment and a relationship cannot be established with other concepts. This situation also led to the fact that semantic processes could not be simulated. In this video, I wanted to prepare a short video with artificial intelligence for you. I hope it was useful. I would be glad if you tell me in the comments whether artificial intelligence is useful or harmful.